Morning. This video is for Mat 151. This is Chapter 11, Lesson 4, Nonlinear Systems of Equations and Inequalities. So our objectives for today are to solve a nonlinear system of equations, use nonlinear systems of equations to solve applied problems, and graph nonlinear systems of inequalities. So nonlinear systems of equations. The graphs of equations in a nonlinear system of equations can have no point of intersection or one or more points of intersection. So just depending on what kind of graphs they are. The coordinates of each point of intersection represent a solution of the system of equations. When no point of intersection exists, the system of equation has no real number solutions. So if you don't get any real number solutions, then that means that the two graphs of the equations do not intersect. We can solve multilinear systems of equations by using the substitution or elimination method that we've used previously. So to solve the following system of equations. The first equation, x squared plus y squared equals 25. Our graph is a circle. We know that from studying our circles. And then 3x minus 4y equals 0. Our graph is a line. So first, we're going to just try using the substitution method. Yes, you could use other methods, but we're going to do substitution for this example. First, we're going to solve equation 2 for x. So you're going to move your 4y to the other side, which makes it positive, and then divide by 3, which gives you x equals 4/3 y. Now that we know what x equals, we can substitute that into the first equation. So when we replace x with 4/3 y in the first equation, we're going to have to square it. That's going to give us 16/9 y squared plus y squared equals 25. Well, when we combine those y squareds, we get 25/9 y squared equals 25. So of course we want to get rid of the 25/9, so we're going to divide it. That's going to give us y squared equals 9. And when we take the square root of that, we can get that y either equals positive or negative 3. And now we know what y equals. We can substitute it back into one of the equations and solve for x. So if I plug in 3 into there, 4/3 times 3, it's going to give you 4. So x can equal 4. Now we had two different y values, so now we have to try it with negative 3. So if I plug in a negative 3 in for y, then I'm going to end up with a negative 4. So my two solutions are going to be 4/3 and negative 4/3. But we always need to just double check that these actually work. So we're going to plug in 4/3 first. So if I plug it into the first equation, is 4 squared plus 3 squared 25? Well, 4 squared is 16, 3 squared is 9. If you add those together, they do equal 25. So that one checks out. It's true. So now we're going to check it in the second equation. So 3 times 4 minus 4 times 3, well, that gives you 12 minus 12, and that does indeed equal 0. So yes, it checks for that equation. So now we're going to check our second point, the negative 4, negative 3. So we plug it into the first equation. Well, if you square a negative, it's going to become positive. So we get 16 plus 9 again, and that does indeed equal 25. So it's true for that equation. So now we're going to check them in the second equation. When we plug in our negative 4 and our negative 3 for x and y, that first one gives us a negative 12 minus a negative 12. Well, minus a negative is going to give us plus, so that's also going to equal 0. So it's true in that equation as well. So that one checks. So we do have two solutions. So now we're going to solve this next system of equations. In this one, x plus y equals 5. Our graph is a line. And then y equals 3 minus x squared. Our graph is a parabola. So we use the substitution method. So substituting, we already have here the second equation is, we already know what y equals the way it's set up. So we're going to substitute that in for y in the first equation. So that gives us x plus 3 minus x squared equals 5. Well, since it has an x squared and an x and some numbers, we're going to get everything to the same side. And then, because it had a negative there, now if we had taken it to the other side, we would have ended up with this one in the first place. But because they had the negative, they just went through and distributed the negative and ended up with x squared minus x plus 2. So then we're going to see if that's factorable. Or we can use the quadratic formula, because I don't know that this one might have worked. So there's the quadratic formula. We're going to plug in our a, b, and c in there. We simplify this. Okay, this one gave us a negative, so obviously it was not factorable for getting a negative there. So remember, that would give you an imaginary solution. So we get 1 plus or minus I rad 7 over 2. Now if it's imaginary, they just split it up into two fractions there. But if we get an imaginary solution, we're going to plug it in, solve for our y. When we do that, we see that we get this equation for our y, 9 over 2 minus rad 7 over 2i. Okay, since both of these are imaginary, okay, then we don't have a real number solution since both of them come up to be imaginary solutions. Which means, since there's no real number solutions, there is no intersection. Okay, so these do not intersect. So if you were to actually graph this parabola and this line, you would see that that line does not pass through the parabola. Okay, looking at the next example. 2x squared plus 5y squared equals 39. This graph is an ellipse. Okay, it's not quite in elliptical form though. And then the second one is a hyperbola. So we can see an easy way to use the elimination method. If you take this second equation and multiply it all by 5, so this would give you 15x squared minus 5y squared minus 5, and we add the equations together, we can eliminate the y values. So doing that, we end up with 17x squared equals 34. And so to finish solving for x, we're going to divide by our 17. That gives us 2. And then, of course, we'll take the square root of 2, which we can get the positive or negative square root of 2 for x. Okay, that is a real solution, even though it's a radical. So if we take that now and we can substitute it back into either one of the equations. In this example, they're substituting it into the second equation here. So when we substitute that in, we have to square this, which is going to get rid of our square root. And they're first just going to do the positive one. So if we do that, of course, if it's negative and you square it, it would also equal 2. So 3 times 2 gives you 6 minus y squared. So then we're going to take that 6, move it to the other side. It becomes negative. So it adds with the negative 1. Then we're going to distribute that negative to both sides. And then we're going to take the square root of 7, which could either be positive or negative, rad 7. That's also a real number solution, even though it's a radical. Okay, so we get rad 2 and rad 7 is one possibility. Rad 2 and negative rad 7 is another possibility. Negative rad 2 and rad 7 is a possibility, or negative rad 2 and negative rad 7 is a possibility. Okay, you could go through and plug those all back into the equations. All four pairs check out, so they are solutions. You could also see this if you graphed both of those original solutions. Now, on Desmos, it will actually graph them. Even if it's a parabola or a hyperbola or an ellipse, you can plug in the equations. On our graphing calculator, it will not show you the whole circle or the whole thing unless you split it up into two separate equations in order to graph. But you can graph these on Desmos and be able to see that yes, they do cross in 4 different points. Okay, for the next example, it says for a student recreation building at Southport Community College, an architect wants to lay out a rectangular piece of land that has a perimeter of 204 meters and an area of 2,565 meters squared. Find the dimensions of the piece of land. So we are given the perimeter and we are given the area. Okay, we know it's a rectangle. Okay, so we're going to have to say what perimeter is going to give us this area. So if we start by making a drawing, okay, and we're going to label just W for the width and then for the length L. So we know the area formula is just length times width. And then for perimeter, we know that we can do 2 W's plus 2 L's and it's going to equal the 204. Okay, so this gives us our system of equations. So now we can choose whether we want to use substitution, elimination, see what we want to use. Okay, well it might be easiest if we just use substitution, because if I take the second equation and solve for L, I can just divide by the W. So once I've solved for L, I'm going to take my other equation and plug in that value for L. Okay, and then I'm going to go through and simplify that. Okay, the W, they took, when they multiplied it, then they went through, they just got rid of that W by multiplying the other side. Everything they multiplied by a W to get rid of the denominator. That's how they moved the W over there, and this one became a W squared. Okay, then they moved everything to the same side. Okay, and then they simplified by dividing everything by a 2. Okay, and then we're looking at seeing, is this factorable? Okay, they're going to see it is factorable. Okay, because 57 times 45 multiplies to 2,565, and then it would add to the 102. So that works. So we have 2 possible solutions for our width, 57 or 45. So now that we know the width, we can plug those back in and try to find the length. Well, if I use this equation here, if I plug in 57, I get 45. If I go through and I plug in 45, then I get 57. So we're just getting the same numbers again, which means 45 and 57 are our length and our width. And generally, length is considered to be longer. So if it has a longer, we call it the length. The shorter one's the width. So we're just going to say our length is 57, our width is 45. Okay, if we want to go and check that, we can plug it back in. That does give us the perimeter. Or if we multiply them, we get the area. So the numbers check out in both equations. So we're going to say that this length of the piece of the land is 57 meters and the width is 45 meters. Okay, on this last equation, they want us to be able to go through and graph this. So what we have to do is we're just going to graph each piece, and then of course using our system of equations we can see where they intersect. And then because this is not equal to, it has less than or equal to 25, and then on the second one greater than 0, we're going to have to use shading, and then where the two things overlap is going to be the actual solution. So if we look at that first equation, it's a circle. So we're just going to graph the equation as if it equals. Since it does have the equal sign there, we're going to graph it as if it has the equal sign. It'll be a solid line. Okay, so then we're going to use the test point 0, 0. So if you were to graph that, it's centered at 0, 0. So that's inside of the circle. Okay, and then this just has a radius of 5, since the square root of 25 is 5. And so if we plug in 0, 0 into our equation, now go back to this original equation. Okay, if I plug in 0, 0 in there, I'm going to get 0 is less than or equal to 25. So that makes it true. So because that makes it true, we're going to shade everything inside of the circle one color. You know, you can do it like lightly colored one color. So if it's inside, then that makes it true. So now we're going to graph the next thing, and this one, notice, is not equal to. So we're going to use a dashed line when we go to graph it. Okay, and probably the easiest way to think about graphing this one, okay, if you were to change that equation so that it's in y-intercept, or yeah, slope-intercept form, we would move the 3 to the other side. So I'm first going to look at it as if it was 3x minus 4y equals 0 for just a minute. If I bring the 3x to the other side, negative 3x, and then divide by a negative 4, well, those negatives are going to cancel out, and I would be left with y equals 3/4 x. There's no plus or minus a number, so we know our y-intercept is at 0. So if you think about that, this is going to go right through the origin. So you can use that to help you graph it. So go right through the origin. We're going to go up up 3 over 4. So it's going to have a positive slope. Okay, we can go through and graph it like that. And once we graph it, and again use a dashed line since this is got a greater than sign. And if you think, if we want this to be greater than 0, if we use a point, and they just chose 0, 2, okay, it is not a solution. Like if I plug in 0 for x and 2 for y, that's not a solution. So we don't want to shade that half of the plane. So we're actually going to shade underneath the line there. So if you shade underneath that line, okay, then we see that we're only going to include part of that circle to make both of those true. So here's the solution, and you have this on your graph there, is we see that the circle was everything inside the circle. Here was our line that we graphed, and we found that it was everything below the line. And so where they intersect is just this part right here in the circle. So to make both of these equations true, it's just this part in here. It does not include the line since the line is dashed. It does include everything on the circle because that's part of it. And it would just be this part in the middle right here. So I'll just kind of shade that here. So everything in this part would be solution for that. Okay, now you can work on your homework for this lesson 11.4 on Math Excel.